So one of the things that's interesting about AutoML that is controversial a little bit is that it is a different way of thinking about machine learning. And a lot of, we'll call this traditional machine learning, has a few things that make it very tedious. So we'll say traditional over here. Some of the things you have to do are feature engineering, for example. And this is a lot of work. So you have to go through and let's say you have tabular data and you have something you want to predict. You have to figure out which features you want. So let's say you're going to pick home prices and predict, what are the correct home prices, or, what is the difference between a cat and a dog or whatever. You have to pick all these features by hand, and it takes a lot of work. Another thing that you have to do is there's a lot of hyperparameter tuning that you have to do. So in the case of, let's say, a neural network, you would have to go through and pick all these hyperparameters yourself, like learning rate and batch size and epochs and activation functions and just a ton of stuff. But if you look at AutoML, a lot of what's happening with AutoML is that the cloud platforms in particular, there are some open source versions of this, but in particular, the cloud platforms are doing much of the work for you. And with a cloud-based ML solution, what happens is that they will do, we'll just call this HP for hyperparameter. They'll do the hyperparameter tuning for you. So a good example of this would be, let's say, k-means clustering. Let's say you wanted to pick how many clusters for your project. You could, let's say there was, you could go anywhere from 2 clusters to 25 clusters. And let's say it was big data. That could really be time intensive, right? You go through, you create, 2 clusters, try it out. Oh, it doesn't work. And it takes 2 hours. And then you go again and you try 4 clusters, try it out. It takes another 2 hours. It could take a long time to find the optimal cluster count. But if you use something like AutoML, it could automatically go through and you give it some kind of a hyperparameter finder, and it would find out the correct number of clusters, for example. And that's just one thing. Another thing it could do is you could give it a model to optimize for. So an accuracy metric. So let's say you wanted to, for a classification problem, you wanted to go through and say, I want you to optimize for AUC, or area under the curve. And that would be a way of making sure that I was getting the best possible classification accuracy. So in a nutshell, what it does is it really automates a lot of the things that a traditional person would do as a data scientist and makes the cloud do it for them. And why is that so important? Well, one of the things that it does that's important to talk about is it has a bigger impact on you as a data scientist, right? So humans become more valuable. So we'll just say humans more valuable. And why would you become more valuable when things are getting automated? Because you can spend more of your time doing the things that a human is better at. And so what is a machine good at? A machine is good at doing the same task repeatedly. You can do the same task, many times. But a human is good at using their judgment, right? So a human could go through and look at, let's say, a whole list of AutoML models that were created. And you could go through and say, look, I can create 100 models per day now. And I was doing that myself, and I was creating, let's say, 1 model a year. But now I can create 100 per day. And I'm going to look at the 100 every day, and I'm going to find the best one, and I'm going to dig into it. I'm going to find out, let's say, why is this one model so accurate? And maybe what I can do is, I can look at the features and see why are the features driving the model's prediction. So you can look at a different part of the problem instead of focusing on doing things that a machine is doing. And this is a lot like the whole point of computers. Like, why do you use a computer? What's the point of a computer? Well, really the point of a computer is automation, right? And so once you kind of think about this, like, why are we doing these things with machine learning, running all these things manually and adjusting hyperparameters when that's not what a human is best at? A human is best at looking at a system high level, like driving a car versus building all the things inside of the car, right? And it's a different level of abstraction. So now that we have maybe a high level overview of why this would be important, we can also dive into potentially some implementation details and also talk about what impact this could have on society. So why would you want better automation as well? So let's look at some examples of problems that you could solve with AutoML that are not being solved currently. One of them would be, rapid detection of disease, right? So we could say that could be one thing that we could do that we're not doing currently. We also could do things like look at mask versus no mask, right? Maybe we could have more pervasive monitoring that allows us to detect when someone is not wearing a mask and they should be wearing a mask, or doing drug discovery, right? Like we're looking for new compounds, and what's interesting is that, and we'll say with AutoML, is that the good thing about a pandemic like this that it showed us is that we have actually the technology to solve these problems, but we're literally not doing it because we don't have enough automation. And I think that's one big takeaway, is that if you for a second think more about the business problem, you can see how you can solve things in a way that doesn't require as much manual building of solutions. So let's look at, in particular, one of my favorite AutoML systems, which is the GCP AutoML. So I'm going to go to GCP console here and walk you through one of the things that I would probably recommend for your final project, which is the computer vision project, or at least it should be in the candidates of how you do AutoML. So if we go to computer vision here, and we'll go AutoML and go to vision, and we go to image classification, for example. I guess one thing to point out here is that there's a couple flavors of AutoML on the Google Cloud Platform. You can do automatic image classification, and you can also do automatic object detection. And in fact, I'm going to go to an older project I have, and I'm going to go to dashboard, data sets. And so here's an example of a project that I ran a while back. And the way AutoML works is that you can click new data set, and you have these options that appear. And this is more of like what a human would do than what a programmer would do. And so as a human, you look at this and you see that I can either detect one thing. So I want to correctly predict whether there's a dog in the picture. That could be one example. Or I want to predict whether there's a dog in the picture or a cat in the picture, right? That would be multi-class classification. Or I would want to find all objects that are in a specific AutoML run. I would say for most students, what I would recommend is probably this, a multi-class classification. And so if you could find really successful projects I've seen students do would be like license plate detection, or trash sorting, like can I detect the different types of trash, or different twins or people in your family, or something like that, or different birds or animals. Wherever you get the data, it doesn't matter. You could go through here. Let's just say it's dogs and cats. Go through here, dogs, cats. We could select multi-label classification, just like this. Let's make it the correct name. And then if I go to create data set, there's very little that I have to do. The only thing that I have to do here is I would have to either upload the images from the computer, and each of the images in the dogs and cats problem would need to have at least 100 images, or I would select a CSV on cloud storage. So in this particular example, this is where I would probably do it, is I would go through and first put my images into a bucket on Google Cloud Storage. So I'd go to Cloud Storage here. I'll show you how this works. Go to the Cloud Storage, either use a bucket you've already created, or let's just create a new bucket. Go through here, create a new bucket, and I could just say, dog cat 911, something like that. And then once I create that bucket, I could then use that bucket to put my data. I won't do it because I already have tons of buckets created. But again, go through there and put your images inside that bucket. And then also select a CSV file that has this particular format. So this is really the most complex part of the whole problem, and it's very simple, which is, put your images, your training images and your test images into a bucket. Then upload a CSV file that has the exact path in Google Cloud Storage to where those items live. And then also have this format inside your CSV file that says what the label is. Is it a cat? Is it a dog? Whatever the label is that you want. Once you do that, and you put that up inside of there, what'll happen is that we will get something like this, and it will show you all of the images that have been uploaded into your system. And this alone is actually very powerful and useful in that it allows you to introspect your data and get very familiar with it. So let's give this a second to load. So let me maybe shrink this down a little bit. It's a little bit too big. So in this particular example, we can see that I uploaded some images here, and there's 3,667 images, and I have 5 different labels. I have daisies, which I can filter by. I have dandelions. I have roses, sunflowers, tulips, right? So I can go through here and pick whatever flowers that I want and kind of go through here and look at all the different things that are in my data set. This alone is actually very useful, and I can go through here and maybe analyze and see if there's something that's bad. Like, for example, if I go to roses, for example, maybe there's some roses here that I want to throw out because they could actually cause problems. Like this one. Here's a image where I don't want this in my training job because this is actually bad data, right? So and again, in most traditional machine learning solutions, you actually don't get this kind of a tool. So it's harder to see that maybe the algorithm you use is good, but your data is bad. And this is the value of using these cloud tools, is that you can start to look at one of the most important parts of machine learning, which is the actual data. If your data is bad, how are you going to train a model? There's an expression called garbage in is equal to garbage out, right? So if you have garbage data, you're going to have a garbage model, right? So now that I've gone through, I've loaded this, the next thing that I would do is I would train the model. And the way it works is once you upload the data, you can select train new model, and you have 2 options. And what's really fascinating about the AutoML solutions that are available from these cloud platforms is that they have often a couple choices. One is a cloud hosted model. So why would you use this? This would be if you wanted to train a machine learning model and then put it inside of a mobile app, or put it inside of, let's say, some kind of, a website, like, let's say, wine prediction, like what kind of wine would you like, or what's the housing price, or something like that. Or the one that we're focused on is you train your model, a computer vision model, for example, and you download the model so you can put it in your mobile device itself, or download it and put it into a piece of physical hardware, which we'll get into next week, like a Coral AI hardware, or a Intel chip, or maybe like a physical device like AWS Deep Lens. Once you've gone through and you've done that, And let's just pick this one for now. If I say continue, if it's the edge-based model, you'll have the ability to toggle between what kind of model you want to create. Higher accuracy, better trade-off, or faster predictions, right? So what do you want to do? Do you want to have better accuracy or lower latency, right? These are really the trade-offs. Let's just pick, for randomness, pick that one. The final thing you'll do is you'll be able to select how many hours you would like your automatic model training to work for. So you can train this for an hour, or you can train it for a few hours. This is really for you to set a budget. Now, keep in mind that they give you some guides here. They can say, if you have between 1,000 and 10,000 images, then you do 4 to 6 hours. If you have over 10,000 images, it would be, let's say, 8 to 24 hours. And also, if we go to the pricing guide, notice that you do get some free AutoML as well. So this is free trial. So it says you can try AutoML Vision image classification for free by using 40 free node hours for each training and online prediction. So actually, this is pretty awesome, because you could 40 free node hours is like, let's say, about 10 free training runs, and then you also get 1 free node hour for batch-based prediction. So after you had trained it, then you can do the inference. And so afterwards, I believe they would charge you $3 per node hour. So and then they even break into what they're actually doing. So these are extremely expensive GPUs, like an NVIDIA Tesla V100. And they kind of go through all the details here of like exactly what it would cost. But in general, if you're just doing a student project, you can use it completely for free, right? And so this is a great way to get experience with using AutoML in the cloud. So let's assume again that you did that. I won't do it because I've already trained this before. What's the next step that happens? Well, the next step that happens is that we would go through here and look at the evaluation. And in this particular example, you can also see the model type. So you can see that this one was designed for the cloud, and this one was defined for the model type right here. So model best type training. And so if I go through here and I select see full evaluation, we can walk through some of the things that you get. In particular, one of the really powerful things that you get here is that you can actually look at all the labels and look at these label accuracy. So if I just maybe make this a little bit smaller, you can see a little bit more stuff. So you can see that I'm able to look at the recall and the precision, right? So these are accuracy metrics, and you can see what the definition is. A high precision model produces fewer false positives, and a higher recall model produces fewer false negatives. And in particular, you can build out this confusion matrix, and it will show you where the model was good at doing predictions and where it was bad. So in this particular example, the daisy was predicted at 95%, but 2% of the time a daisy was predicted as a rose, 2% as a dandelion, and 2% as a tulip, right? And likewise, the dandelion was predicted incorrectly as a daisy 3% of the time, but it's got 94% accuracy. And you can even look at each one of the labels as well, and you can see exactly what's happening. And this again is awesome, right? Because you can build through and look at exactly what are the true positives and see which ones were successful. You can also look at the false positives here and see which ones were unsuccessful. And then you also can look at false negatives, right? So you have a complete high-level overview of all the different things that are happening inside of this AutoML platform. And so finally, what that allows you to do is if you go to test and use, you can go through and then export this model to one of your physical devices. And so this is the part that I would recommend really paying attention to and being careful with is, how do you want to use this AutoML system to create a solution? And there's a few different options. So one option is that you can use TF Lite, and TF Lite is an emerging standard for doing small TensorFlow models. So this behind the scenes is using TensorFlow, but it's actually exporting a model as TF Lite. So if we look at, let's say, the Android Quick Start here, what you'll see is a tutorial where they show, after I've trained the model, how I can go through and export that model to my edge device. So here we go. What will we build? So in this tutorial, you're going to download an exported custom TensorFlow Lite model using the AutoML Vision system. And you can also start with a pre-made Android application right here that uses the model to identify images of flowers. So if we scroll through here, you can see that TensorFlow itself is the main thing that we're going to use. So before you start, the main thing to do would be what we just went through, right? Is train some model. And it could be anything. It could be something that you downloaded from Kaggle, which is the training data. It could be something you created yourself. The reason why I think this is kind of interesting is that, with Kaggle, for example, one of the problems with Kaggle is that you're using other people's data and other people's ideas. But with this, you could use your own data, right? You could create anything you want, and you could actually control all of the training and what it is you're actually doing in terms of creating machine learning. And then next up, once you've gone through and you've trained it, this would be the steps that you would need to kind of get started. So first, you would install TensorFlow. You would clone this repo. And then what would happen is that you would go through and set up Android Studio if you don't have it installed. Now, again, this is just for Android. If you wanted to do it with iOS, I'll show you that one as well. But with Android Studio, you would open up a project and then say open an existing Android Studio project. Next, you would go to the file selector window and choose TensorFlow project. And then you would open up the project and you'll get this Gradle Sync pop up. So this is using the Gradle Sync wrapper. Next, you would go through and test run the app, and then set up an Android device, and then set up the emulator with camera access. And then once we scroll through here, you can see that you can create a new device inside. So here's an example of the new device. And then you can verify the configuration page. So here we go, show advanced settings. And now with the advanced settings displayed, you can set both the camera sources to use the host's computer webcam. Here we go, webcam. Now, once I go through and I run this original app, I can go through and select the device, and you'll also tell it to make sure that the TensorFlow demo that you downloaded can access the cameras on your device. So this is important because you are going to, once the model is downloaded, you want to test it out, right? And this is the real world, right? In a real world production system, you want to test it on real data. And so once you've done this, you install it, and it comes with this particular version. It actually doesn't require any AutoML because it has a pre-trained model that's included that you input on your device. And the model should look like this, right? So here's an example where we do a prediction. Now, you go through and you run this customized app. So the default app classifies something into the one of the 1,000 ImageNet classes. But if you've trained your model using AutoML, we can download the graph Lite and the labels text file, right? That was in the field. If we go back here real quick, let me just point that out. Notice that when I do an export, that it will put the TF Lite file will come out, right? So we train it in the cloud and we just dump this TF Lite model into our physical device, like our laptop. And so once we do that, we just put the graph Lite and the labels text file into this Android TF Lite app source main assets directory. So we take the new model and we put it in. We're basically replacing the brains of this application. Once we do this, we modify the application a little bit, and there's a teeny bit of coding, not a lot of coding here, and then we go through and we run it again. And what happens is now we can train it on the new data that we've classified. So the new model. So what's interesting about this is that what it shows is that not only can you use AutoML, but you also could take some other model that was created somewhere else and put that onto here. But because this class is about doing machine learning yourself, really I think the AutoML workflow is probably the best one to focus on. But yeah, again, we download this, we put it through there. And so, what's happening here is that this app is using a precompiled Android archive file. And once you go through here, you can make an inference using the TF-Lite Java API. And this instantiates the TF-Lite interpreter. So it has an interpreter that can read inside of the TensorFlow predictions. And then it goes through and it runs the model. And then we're able to do the predictions and show the output. So this, I think, is a very good example of why AutoML is so powerful. Now, the other thing to also point out here about this TF-Lite system here is if we look at TF Hub, is that you can find actually existing models inside of TensorFlow Hub here. And in particular, you can look for the word TF-Lite like this. And there's a whole bunch of models that you could even try out to see how they work. So here's an example. This was updated 820. And if I look at this model, we can see this TF-Lite model in this collection are compatible with MLKit, Google's mobile SDK that makes it easy to use ML in your Android and iOS apps. You can use these using MLKit's image labeling and object detection and tracking APIs. So how do you do this? You download the TF-Lite model from the model details page, pick a model with metadata, and then go through and follow the advice inside of here. So not only can you train a model, again, yourself using the AutoML system, but you also can use pre-trained models and download those. So I think this is probably one of the more interesting workflows that I would recommend that students try. Now, there's a second option that I'll also show real quick is how to use the Apple workflow here. So here's an example of how to use the Apple workflow. So with Apple, you can actually replace the existing machine learning model and convert it to a core ML model. And you can do that with a library that they include. I think they tell you about it here. The core ML framework has the ability to import models from other languages. And so that's one way that you can use it. A second thing you can do, though, as well, that I haven't yet seen a student do, is that you also could use Create ML and train the model by using the SDK that comes with Swift. So here's an example of a second approach that you could do. So you could not use Google Cloud, and you could use Create ML. And if you're familiar with Swift, what you could do is you could put some images inside, click Create ML, and then create a Create ML model. And what would happen is that it's this workflow. It's a high level workflow where you, just like Google Cloud, you put the data in, you do the training, and you do the evaluation. Now let's take a look at this one. I think would be a good example of this. Make this a little bit smaller. So if you wanted to train a classifier completely with essentially high-level GUI tools and using Swift, you could do something similar to what we covered with Google AutoML. Is you just need to create a directory that has the images you want to classify. So in this case, we have elephants, giraffes, and then you would label those images and put them into Create ML. So here's a kind of a step-by-step example. They're mentioning that you should have at least 10 images per category, and then balance the number of images for each category. So, ideally you would have, 10 images for each category, or 1,000 images for each category. And then once you've organized your data, you want to put it into the training data set folder by having a folder called training data and then putting again the categories. And so once you've organized your data, then you also want to have testing data. And your testing data is a great way to see how well the model is trained as well. And once you've got the test data and the training data set up, then what you do is you'd say create a image classifier project. And then you would use CreateML to create an image classifier project by using Xcode Open, right-click on Xcode icon, open developer tools, CreateML. And CreateML is actually one of the templates now that's available in the SDK. Once you've done that, you would go through and say click training session, and then you would take your training data and drop it into the folder, and then you would go through and see as well if you want to add some augmentations to it. So this is one of the things I think that Apple is doing better than Google, is that this is free, right? You can just use your laptop to do this and drop the data onto this training data phase, and then also add your own augmentation. So a lot of times when you're building a model yourself, one of the problems is you don't have enough data. And so one way to get around that is you can add augmentation to get more of a signal, right? So you could add noise, blur, crop, flip, rotate, so that each of these become new inputs to your model. So it's better able to generalize different views, right? Then you go through and you also put your testing data here, and you even select how many iterations you want to do. Finally, if you know how many training iterations you like to use in a training session, you change the maximum iterations from the default value. Once we've done this, then what we could do is train the classifier. And then in this particular example here, click train, start the classifier, the CreateML session begins, and then you can start to see how it works over time and how many iterations. And eventually it could, once it gets to the highest level of accuracy, then you don't need as training anymore. So there's a limit to how many training runs you are going to work and to make it the most accurate. But what I like about this as well is that it's got all this built-in tools for you. And again, it's completely free. And so I haven't yet seen a student do this one, but I would recommend, if you're interested, to try this approach. Now, if you're an advanced student, maybe you try both approaches. You do the Google AutoML, go through, train the model with Google AutoML, put it down to Android, and then second, go through and train it with CreateML. If it was me, I would probably be the advanced student. I'd want to do both. It's up to you which ones you want to do, but I think there's a lot of value in trying both. And now, if we go through here, you can preview the results of the model and try it out, and then save the model, right? And then you can actually share the model if you want with someone else, and even you could take this ML model and even give it to some other application. And this is something I'll talk to you in a second about model portability. But once you've done that, you just add the model to your application. And this again could go to that sample app. You could just swap it out. So this sample app here is already ready for you, and you could actually just swap out the model which lives inside of here with your own model. And then finally, but yeah, that's pretty much it. So let me talk about this though. So they talked about this ML model and like the portability. So one thing that's an emerging standard now with AutoML is something called Onyx. So I'll get into that next. So ONNX. And Onyx is called Open Neural Network Exchange. And so this is an open standard for machine learning interoperability. And so this is an open format built to represent ML models. And so you can see some of the different key benefits here. Interoperability. So develop in your preferred framework without worrying about downstream inference implications. So Onyx enables you to use your preferred framework. Also hardware access. So Onyx makes it easier to access hardware optimizations. And so a good example of this thing, if we go to get started here,
is that you can export things. Once you convert from Onyx to another framework, you can actually you can basically interconnect with any of these, right? So these are all frameworks and converters that you can use. So MXNet comes out of Amazon. We know scikit-learn is an open source machine learning library. PyTorch is out of Facebook. We also have TensorFlow from Google, SAS. Anyway, you can go back and forth between these different frameworks by using this open Onyx system as well. One of the things that you can do is, here's the cloud service, is that Microsoft also has the ability to do AutoML. So we already talked about Google. Now we talked about Apple. Now we talk about Microsoft. So Microsoft, here's a good example of how you could do AutoML from Microsoft. So the way you do this is they have something called Custom Vision Service with Windows ML. And so if you've trained your model with their AutoML system, their computer vision system, you could then go through and export this example code here. So this example application is available here. So let's go ahead and click on this. This is probably a Visual Studio Code example. And you can see this is an Onyx model that's exported from the computer vision service. And it walks you through how to add your own sample model from your classifier. And so first you would create and train a classifier with the computer vision service. So this is, again, is a third option that you could choose. And so if we go through here, let's actually walk through how Microsoft would like you to train a classifier. So step one, you would build a classifier through the website. So you create a custom vision resource in Azure portal. So create a new project. And then you go through and you create a new project here. And notice it's very similar, again, to both Apple and to Google. You would do the project type. Do you want to do classification? If you do you want to do multi-label, so multiple tags per image, or multi-class, a single tag per image? And then domains. So what are the kind of domains? This will help the computer vision algorithms converge more accurately. Go through, create your project, and then select, again, what it is you want to do. Notice as well, they mentioned this inside of the available domains, that you can optimize things for food, landmarks, retail. Finally, you go through and you choose your training images. So they're recommending that you use at least 30 images per tag in the initial training set. And so in order to train your model effectively, you want to select images that vary by camera angle, lighting, background, visual style, size, type. Then you go through and upload and tag your images. So you would add images, clicking the Add Images button, and then select Browse Local Files. Then select Open to move to tagging. And then your tag selection will be applied to the entire group of images. Then once you've gone through and you've uploaded those images here, you can then train the classifier. So again, it looks very similar here. So I go through, I select the train button, the classifier uses all the current images, and then finally I evaluate the classifier. And again, just like Google, just like Apple, to train the classifier here, we would evaluate precision and recall. So this is precision is the fraction that were correct, and then recall is the fraction that were correct, the fraction of the actual classifications that were correct. And then we look at the probability, like how confident is the model, and then we look at the different iterations. So once you've done all that, the next thing, if we go back here, is that you would then go through and export your model by going to the Performance tab. Now look, they have this thing called Onyx. And what this Onyx, why is Onyx so awesome, is that once it's in this open format, I can convert it to some other framework or some other system and some other target. And so once you've done that, you can drop it into this sample project, and then you can kind of get this thing running. So I guess in a nutshell, what's really powerful here is that all of the main cloud providers have their own AutoML vision, or a lot of the big companies have their own AutoML vision system, and they're really kind of hoping that you get involved with one of those solutions, and they make it very, very easy from a high level, and in particular, this Onyx format here, I think, is one of the more interesting ones. So that you can leverage cloud services. Now, another one that I think is a very interesting thing to consider is that this Onyx format has something called Model Zoo, and this could be thought of in a way as a competitor to TF Hub, right? We were talking about earlier where you could go into TF Hub and for example, I think it was here, I could go through here and look at TF Lite models and even look at what are the different problem domains, classification, style transfer, whatever I'm trying to find. Likewise with Onyx here, this Model Zoo, I can actually look at all the different models that they've given for you. So here's one called object detection and image segmentation, body, face, and gesture analysis. Here's a bunch of them. We also have, these are the object detection and image segmentation. So real-time CNN for object detection that detects 20 classes, SSD, faster RCNN. So it's really another way to train your model. So let's actually maybe whiteboard all these different solutions and just talk through the different choices that you can do when you're building a machine learning model from scratch, and why we have so many incredible solutions. So to start with, when you're building computer vision models in particular, let's just put this thing on here. There's basically three great ways to do this. So for your final project in particular, hopefully this thing will wake up. Yeah, I think that this thing should wake up. Okay. There we go. There it woke up. So we'll call this computer vision options. So we know that we have Google, so we have the Google Cloud, and with Google, there's really two branches that you could do. The first branch would be Cloud AutoML. And the second branch would be, we have Cloud AutoML, and then we also have TF Hub. And with TF Hub, what we do is that we would be able to, in both cases, generate these or use a TF Lite model, right? And with TF Lite, we know that we could take this model and we could put it to let's call it an Android device, right? And so this is option one for students, right? Is go into Google Cloud. If you like Google Cloud automation, upload some images, click some buttons, train a model, dump out the TF Lite, put into Android, do a prediction. There's sub options, right? So that's in one, we have 1A here. And then we have 1B right here. So here's number one. Again, number one. And then we have number 2. So TF Hub. So in TF Hub, you don't do anything. You just literally go to TF Hub, go do a little search inside the console, find the classification model you want, and download it and put it into your system. If it was me, I would try both. Why not try both of these? See what it's like and see how it feels. I think the more interesting one is probably to train it yourself so that you have the experience with doing it. But that's why I would try both. But again, this is option 1. Option 2, which we talked about, is Apple. The Apple has a SDK called CreateML, and with CreateML, what you do is you download the model and you put that model onto an iOS device here, right? And the SDK itself does all the work using a GUI tools, right? And some of the advantages of this is it costs nothing, right? It doesn't cost anything. You don't have to go to the cloud, do all this stuff, and the tools are pretty interesting. There's also option 3, which is, by the way, there's lots of options. These are just 3 that we're talking about today, but now we also have Microsoft, right? And so Microsoft has this they call it, what do they call this thing? Custom vision service. So they have custom vision service. So we go back here and we have a custom vision service, custom vision service. You go through here, you use their AutoML system, and then once that AutoML system is done, you put that onto some device, let's say iOS or something like that, and then you can do the predictions on that device. Also, they have option B, so I guess that'll be 1, this would be number 2, this would be number 3, is they also have number B here, which is the ability to do a download. So they call it the Onyx Zoo. Onyx Zoo. And so the Zoo, you again download an Onyx file model, and then you put that to some location. So I think this is, in a way, the world we live in. We're blessed because there are many ways to build very, very quickly AutoML solutions using proprietary tools. So Google, Apple, and Microsoft. So maybe I should classify this and say these are proprietary tools. So we call this proprietary tools, right? Now let me talk about another solution as well that's an open source solution, which is something called Ludwig. And I haven't yet done this myself, but if we go to Ludwig here, and we go to this, this is an example of a open source tool that also is similar in a way to maybe the Apple tool, but a little more low level. And what you would do with this Ludwig tool, first of all, it's a Python library. You just say pip install Ludwig, and you would go through here and do a image path. So you would create an image path that has a directory and a image inside. You would go through and create a class here, and this class would have the different types: car, dog, boat, whatever. And then to run this, you would do Ludwig experiment, pass in a CSV file, which has the information about where your data lives, like again, the path and the classification label, and then also pass in the model definition file here. And so with the model definition file, we will put in an input feature like name, image path, type, image, encoder, stack CNN, and also the output feature, so class, category. And then what we would do is add a complete example of a training and image classification model on the MNIST dataset. So you could then go through here and like download MNIST, clean up the data a little bit, and then now you should have this file here, this MNIST training set data. Go through and train the model. So you would again give it this model definition, which would look like this. And what's great about this is it's a little bit more low level in that I'm using an open source library, and I'm able to pass in the encoder, which is a stacked convolutional neural network, and also put in the convolutional layers here. So number of filters, filter size, pool size, and then put the dropout rate. So in this case, it's 0.4. Do some image captioning here. So in this case, we have image path and then the caption, and do a similar thing. So basically, in a nutshell, you can also do very similar things by using a open source tool as well. So if you're a very motivated student, this might be something to think about. Is could you even add option 4, which we don't have room to put this here. Maybe we do. Let's see if I can put yet another option, which is, can you do an open source tool like Ludwig, right? So number 4 would be Ludwig. And what's interesting about this is that there's a lot of ways to solve the same problem. And now let me start to talk about moving the model around. And let's go to this next section here. So this will start to get into some of the things we'll talk about next week. But one of the things to talk about is model portability. And this might be one of the more interesting things that a human could be doing right now. Because what's fun about it is that we're in an emerging field for model creation. So we just talked about it. You can get it from Apple. They can create models. You can create models from Google. They've got stuff to create models. You've got Microsoft. They can create models. You've got open source models. You got tons of different models, right? And one of the key concepts here is, how do you move to different formats? And so one of the ways that you can do that, again, we're just talking about this, is this Onyx format. And what's interesting about Onyx is that with Onyx, you can actually not be afraid that the model came from somewhere else. In fact, you can embrace it and you can say, great, you created a model somewhere else. Now let's convert it to some other framework or other platform or other deployment target. So you can convert to frameworks, right? So let's say it originally was coming from TensorFlow, but you want to move it to, for example, scikit-learn or PyTorch or some other thing. You could convert it. So let's just say it came from PyTorch and you wanted to move it to TensorFlow. You could do that. You also can move it to different targets. And I think this is another emerging category, which is, where do you want to deploy to And a lot of times what people want to do is they want to go to an edge device. And what's interesting about an edge device is that the edge devices themselves have special characteristics. And these special characteristics could include the size, right? So mini edge devices, and I think I have one somewhere around my room, but basically, you get a little device in fact, I have one right over here. It's right here. I have maybe a couple. Yeah, so I could just take the model and put it onto this, and we'll do this a little bit later next week. I'll go through. I'll convert it to a device. You can put it to Intel Movidius, right? These are devices. So the portability of the size is an important factor in moving to a small device. So we could say size. We could say form factor is another one, and then also potentially the kind of target. So do you want it to be, let's say, available offline? These are things to think about. Or do you want it to be a mobile device, right? And so the coming world, I think what we're going to see is the concept of IoT or Internet of Things, that many devices now, because of this model portability, the Onyx format, the different ways that you can do things, is that probably most devices that you use are going to have some kind of machine learning model built into it. And not only that, but most of these IoT devices will probably be integrated with everyday life. So you could think about your house, that almost every aspect of your house could have some kind of machine learning model built into it. So it could be, the kitchen, all of your kitchen devices, it could be the alarm clock, your internet itself. And so as a result of this, we need to have a very fast and fluid system that can train things in many different clouds, convert them to different formats, and then also allow us to deploy to many different form factors. So that's really, in a nutshell, the high level overview of computer vision and how we have so many different options. So now that I've covered the basics of that, let me now show you a couple things specifically to do with AutoML in the cloud platforms. So let me start with AWS. Let's go to a new cloud now. And with AWS, they have a neat AutoML system called, it's actually called machine learning. So it's not a great name. So let's go through here and let's go to auth here. And we'll go 025. Here we go. All right. So I'm logged in. And in particular here, what I'm going to do is go to this service called machine learning. Here we go, Amazon Machine Learning. And what it does is it allows us to do automatic machine learning by uploading CSV files. That's it. So it takes tabular data. So I'm going to look at an existing data source here. And here's an example of where this is a file that lives in an S3 bucket. And if I grab this, I can go through and do a new, actually I'm going to start at the very beginning. I'm going to go to dashboard. I'm going to create a new data source and new model. So again, imagine we're starting from the beginning and I don't even want to write code. Maybe I'm not even a data scientist, but I know enough that I think I should do some machine learning and I want to create a prediction model. Well, you can do this, right? And here's an example. I can go through and I can put in this bucket that has this banking data inside. And then I just need to call it something. In this case, we'll call this banking data. And if I verify it, what will happen is it'll introspect the schema and show me some things inside. So there we go. We're able to inspect the schema. Nice. So now that I've got the schema, notice that it says, does the first line in your CSV contain column names? We'll say yes. There we go. And then you can notice here that we've got name, data type, right? So we have actually numerical data that is correctly identified, categorical data, right? And there's actually 21 columns. And notice that if I go to the last column here, if I go, that this one says data type binary. This is the one that I'm going to predict later as the target. So I'm going to say, because you picked the combined create ML model and data source wizard, you must pick a target. Okay, great. So let's go ahead and do that. I'm going to go back here again. I'm going to select Y. I'm going to say continue. And it says, does your data contain an identifier? There we go. And I would say yes. And I would go through and do continue. Now, once you've done the ML model settings here, it says you can use automatically suggested ML model settings, or you can choose to customize. You have two options. You can do default or recommended. So generate a default recipe, use default training parameters, set aside 30% of your data, or you can do custom. So you can modify the recipe. I think most of the time, most business people, for example, or even, if you want to do this, just pick the default. And notice though, it does all the right things for you, right? But this is what a data scientist would do, a highly paid data scientist. So we go through here and we say review. And now look at it, picked these advanced settings for me. So it goes through and it shows me the regularization type and shuffling type, for example. And we go through and we create a model. And now it's doing the training for me. So it's a pretty straightforward process actually that will go through and it'll train this model. Now, because I've already done this many times, I'm going to go back here and I'm going to look at an existing model that was trained. And so we can just look at the results here. And if we see this, we can see that an evaluation was performed. And this is actually the result, which is 0.936. And it gives me a pretty good visualization, right? It says, on your most recent evaluation, the model score was extremely good. Here's what the prediction is 0.936. And I even can go through and look further into the details. So I can see, for example, that this model has a 91% accuracy, and there was 581 true positives and 10,676 true negatives. But if I want to get into the errors here, this might be one of the things that's very important depending on what I'm doing. Let's say it's COVID, right? This is a very important distinction. Maybe I care less in the case of COVID-19 about the accuracy, and I care more about the errors, and especially about the false negatives. And so what I would do is try to minimize the false negatives. So I would move this down lower, 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 until I get to a very low, almost at a place where the accuracy doesn't get too crazy off. But let's say we want to do this. So 80% of the time it's going to be correct. And we overclassify. We tell a lot of people, oh, you probably have COVID-19, but we want to minimize the false negatives, right? So this might be a decision you would make when you're building one of these kinds of tests. And then you could save the threshold like this. And then now you've got a machine learning model and you can run it into production. So I think this shows the advantages of using these AutoML tools. So this is AWS's AutoML. Now let's look at Azure's AutoML next. So the next one we'll get into is Azure. And if we go into Azure, there are some great AutoML features as well. So with Azure, if you go to AutoML, one of the things that you can do is go to their machine learning interface and go to a workspace and launch something called Azure Machine Learning Studio. And Azure Machine Learning Studio has a bunch of kind of hooks here that allow you to do things. In a nutshell, though, the main takeaway is that in order to do anything, you have to have a compute cluster,
and you have to have a notebook. But with this, you can see with AutoML, you can automatically train and tune a model as well. So if we go to a notebook here, what I could do is I could look at one of these sample notebooks, toggle through and find an example of how to use Azure ML. And look, here's an example, Azure AutoML. And there's a bunch of different things. In fact, this is the exact same data set that I was just using on AWS. So if I click on this, I think I might even have it open, but I don't remember if I do. But sure, let's try it out. Let's clone this notebook, and there we go. I think I might have already opened this at one point. So what I can do is just go to a notebook, and I can just go here. Let's see, go to notebooks, home, and designer notebooks. I think I should have one open already. Here we go. Yeah. So I was just going through the wrong way. Okay. So if I go to this notebook, we can look through, and I think I probably already have one running. Let's find. Okay. So in this particular example, I have AutoML bank marketing data. And so we can just even read through, because we didn't get that information before. In this example, we're going to use the UCI bank marketing dataset to showcase how you can use AutoML for classification problem and deploy it to an Azure container instance. The classification goal is to predict if the client will subscribe to a term deposit with the bank. And so in this case, we want to know if they want to basically, I think, give us a CD, right? Or would they give us some money? And so you would create an experiment. You would run AutoML using something called AutoML config, which is how they handle AutoML. Train the model using the local compute with the Onyx compatible config on. So what this would do is it would tell it that I want to export that model in Onyx format so that I have a lot of portability with it. And you also can explore the results, look at the features, like how were the features generated, and then also put the model into production using this inference endpoint with Onyx, right? Register the model, create a container image, create an Azure container instance, and then test it. So how do we do this? Well, the first thing that you would do is that you go through and run these features. So I would go through and in fact run this. So I would go through, build this thing out, import this library, and then once I've gone through and I've done all this, you would set up a workspace. Here we go. Here's a workspace. Attach your compute instance to it, and then what you would do is load in your data. Here's the data to load in, and then go through and tell it what your test data is, what your validation data is. And then when you do AutoML itself, you still have to do a little bit of work, but basically you tell it the different things you want it to automate. So am I doing classification or regression? So you have to know something. Like you have to know if it's a classification, regression, or forecasting problem. In this case, it would be a classification problem. Then you tell it what is the primary metric you want it to optimize. So for classification, it has support for the following metrics: area under the curve, precision score weighted, etc. Also, what are the timeouts? And then also what are the ones that you don't want it to run, right? Because this is expensive to do AutoML. So maybe you just don't want it to run certain models, right? And then as well, is there an exit score for a termination of the model, and how many cross validations, right? There's actually a lot of things you can just toggle as well. But what does it look like? Here's an example: is you would say with AutoML, listen, I want you to do, I want you to time out after 0.3 hours,
I want you to be able to stop early. I want you to at most run 4 different kinds of training jobs. And my primary metric is AUC weighted. Once I've got that AutoML config, I pass that into this object, and then I put a couple other things inside. So I say, don't do k-nearest neighbor, don't do linear SVM. Make sure, again, that it's Onyx compatible so I can export it, and then pass in my training data, validation data. So, but again, it's even though we're writing a little bit of code, I'm not doing the ML myself. I then say submit it, and it runs. Once all this runs, then I can actually go through and pick the best model that's run, and then visualize it. And I think I've run this before. So let's see. Is it? I believe that here's an example of the actual Onyx model that I could download it. So if I needed to, in this case, you can see it's size 1.2. I could actually download this and then run it somewhere else. So I could run it in anything that supports the Onyx format. I could put it onto a inference device. I could convert it, make it run into scikit-learn, or put it on another cloud platform. But let's also look at the other interface here, which is if we go to experiments and I look at this AutoML classification bank marketing data, we should be able to look at a job, and I can see this job and see the results. So what happened was it went through and run a bunch of different models for me automatically. And in this particular example, it picked the voting ensemble, right? And you can see that it was a classification problem. And we could even look, I think it'll tell me different criteria and all the things that it ran. But if I look at the there's a way to look at the explainability as well, which I believe is under models. Let's see here. Yeah, if I see models here, you can see every single model that was run. It ran through a bunch of different models, and this is the one that was the best model. And it only took 1 minute and 4 seconds to come to the correct result. And I can see the explanation. So if I look at the explanation, this is really where I think things are better when you're doing AutoML with a cloud platform versus doing this yourself, is that instantly I get access to really key bits of information. For example, what are the features that are most important in providing the prediction value that it provided? So in this case, we can see that the duration is the most important feature, or the employed feature is the most important feature, right? And I also could look at other things as well. I could look at summary importance, and this shows me, I believe, the absolute value of the feature. So this says the global feature importance is calculated by averaging the absolute value of the feature importance of all points. So in this case, both positive and negative cases, how well does it perform? And you notice that this duration, so if you remember, what are we trying to do? We're trying to predict whether someone will give us a deposit. Like, essentially, will you buy a CD at my bank? The most important feature in both selecting whether they say yes or no is how long of a member they've been. And then the second most, which is pretty intuitive actually, is if you don't have a job, you're not going to be giving the bank money. And you can see that it's negatively weighted against giving the bank money, right? Heavily negative weighted. And also we can see that there's other features like in here as well that we could look, but a lot of them are negative, right? But it looks like the one that has a lot of the positive classification characteristics have to do with how long they're a member, right? So, which again makes a lot of sense. Like if you're a member of the bank for a long time, then maybe you're very happy and maybe you have a lot of money, and so you're willing to loan the bank more money as well. So this lets me look through and explain the model. So as a data scientist, again, what this allows me to do is more focus on things like the feature engineering and the explanation of what I'm trying to do versus trying to get in and recreate the wheel completely myself. So that's Azure machine learning. Let me also show GCP has a different AutoML solution that I'll just quickly talk about here, which is they have a tabular data AutoML solution. And if we go, I think we just have to type in GCP tables AutoML or something like that. And AutoML tables enables your entire team to do state-of-the-art ML on structured data or tabular data. So if we go to console, we can go here. It's very similar to the computer vision AutoML. What you do is you say new data set, and we can again put in something in here. And then from here, you would put in your tabular data. Now, what's interesting about the tabular data is that you can import data from BigQuery, you can select a CSV file from cloud storage, or even you can upload files from your computer. I think probably BigQuery or CSV file are probably the two most compelling. Now, BigQuery is pretty interesting because you could actually go to BigQuery, find a public data set, find some really cool data inside of BigQuery, then put the project ID, the dataset ID, and then the table, and then import it, and then actually train a machine learning model based on that, which would be actually pretty interesting. But once you've done it, let me just show you a model that I've created a long time ago. Here was something where I was predicting the income based on different criteria. So, I was classifying whether someone would have made over $50,000 or under $50,000. And I, again, imported the data. When I went to train the data, what will pop up is this, and I'll make this a little bit smaller, is that you can actually look at the column name, the data type, the nullability, the missing count. So basically it gives you like descriptive statistics around the column or the spreadsheet that you uploaded. And then really the only thing you need to do is select the target column, right? In this case, let's say I wanted to predict whether someone was married, right? I could look at these. And in fact, this could actually be pretty accurate to predict whether someone was married or not, or like we said before, income or some basically some kind of categorical data, like or binary classification. And I also could even use feature engineering because it would show me, I could even sort through and see which values are most closely related with income, right? In this case, we can see age, relationship, how much education you have, which is intuitive, right? Would be highly correlated with how much money you make. And then once we click on training, we would go through here to the models and see what the accuracy is. And so this model is okay. It's got a decent level of accuracy, but I could actually evaluate it and look further and kind of dig into, what are the things that it was good at. And if I look at the confusion matrix and the feature importance, this also has the same thing. So we can see that, which also is, I guess, intuitive in terms of income, is capital gains, what age you are, marital status, how much education. So this, I think this one was for your predicting your income level of classification, is that age, marital status, and education and occupation, these are all factors. So maybe one takeaway here is that if you want to make more money, you should get married, right? That's one of the key factors, and get a lot of education. And the older you get, right? These are all values that help predict it. So in a nutshell, though, I think that the main takeaway to wrap up everything we talked about is that these high-level cloud tools can really add a lot of value and make things so that you're focused more on the business problem and even potentially more effective as a data scientist.